Hello, so continuing on this contest 161, this is the problem number 1249, 1249. The problem says minimum remove to make valid parentheses, and we get a string of open and closed parentheses with some lowercase English characters, and we want to remove the minimum number of parentheses, open or closed, in any possible position so that we can get a resulting parentheses string that is valid. Basically, a string with open and closed parentheses with other lowercase characters that doesn't have any extra closed or open parentheses. And so basically, just formally defining what a valid parentheses string is, it can either be an empty string or contains only lowercase characters, no parentheses, or it can be in the form AB, where A is a valid parentheses string and B is a valid parentheses string, or it can be like A between parentheses, such as A also is a valid parentheses. So here we get this example where we can just remove this last parentheses to get a valid one, right, with open and closed parentheses each time. We can also, another option is to remove this parentheses here and get a valid one, or alternatively remove this one and get a valid parentheses string too. For this one, we need to remove this parentheses here to make it valid. And yeah, you get the idea. So let's see how can we. Okay, so how can we solve this problem? So whenever we have a problem like this that asks about valid parentheses, we should directly think about using a stack. So let's take two examples, one with an excess of closed parentheses and one with an excess of open parentheses, just to get a sense of how can we solve the problem. So let's take as a first example with excess closed parentheses, something like this, where we have, let's say, and then E, and then this. So we have one extra parenthesis like that. So if we put stack, we put the content in the stack. So while pushing into the stack, we can keep track of the open. We can keep track of the open and the closed parentheses, right? So let's say this is the opened parentheses, and then C, let's call it the closed parentheses, right? So here we have O, and then we have C, right? So first, when we pop C, they are all at 0, and then we push open parentheses, so now it's 1. And then we have O, so we push that O. And then we have D, so we push it, and then we have a closed parentheses, so now we have 1. And then we have a closed parentheses, and then that's the one there, and then we have E, and then we have another closed parentheses, and we have 2. So that's where we can do something here, because whenever we have one open parentheses and then we have 2 closed parentheses, whatever comes after doesn't matter, the string will stay invalid, right? So we know that we need to remove the closed parentheses that makes the number of closed bigger than the number of open to have any chance of finding a valid string, right? So that means that while pushing in the stack, whenever closed is bigger than opened, don't push don't push in the stack. Alright, just because if we push it, that means the result that we are going to get later is going to not be valid, right? So we are not going to push it, and we are going to consider, so not pushing here just means we are removing these parentheses, because at the end, whatever is in the stack is what we are going to use as a result. Now the question becomes, okay, what if we have an excess of open parentheses, like in this case, let's say we have C, O, D, E, and then 1 closed parenthesis. So we have an extra parenthesis here. So what we can do in this case is, since when pushing, we don't know if we have an excess of open, because maybe there is a closed parenthesis later. So when pushing, it's hard to know whether we should remove an open parenthesis or not. So the idea is to remove it when popping where we are constructing the result, right? So let's make the stack for this one. So we don't encounter an excess of close parentheses, so we don't remove anything, but we get something like this, DE closed. And at this point, our open is equal to 2 and our close is equal to 1, right? So we didn't encounter any close that is bigger than open, so we didn't remove any closed parentheses, right? Now when popping, we will construct the result, but since we are popping in the reverse, anytime we pop a character from the stack, we will need to add it first, right? So that it can become in the right order, right? But the thing is, what we can do here is that we can reinitialize our open and close parentheses to 0, right? And then whenever we encounter a closed, we increment, right? So when we encounter closed here and remove it, then our res will become, let's put our res here, and our close here will become 1, and our open will stay 0, and now res will become like this, will contain a closed parenthesis. And then we pop E, and we add it to the res, and since we are adding at the beginning, we will put it here, do the same for D, and then pop the open parentheses, right? Now we have another open parenthesis here, so we have 1. They are still equal, so nothing to do. And now we remove the O and then add it here. So we had that and then remove the O. And now we have an open parenthesis. So now we have 2 open parentheses. Now it's where we are going to do the removal. So whenever opened is bigger than closed, that means remove the open parentheses. Why is that? Because whenever you have something like this, and we already know that we won't have any more closed because we are already pushed everything into the stack. And so no matter what happens, if we have a closed here, that won't help us, right? And so we know that immediately we need to remove this one, right? So that's why we remove when popping. And so since we remove, that means we won't add it to the result, and we will just keep this one at 1, and we'll remove it from the stack without adding it to the result. And now we pop the last C and end up with a valid result, right? So the gist of this approach is push into the stack, but keep track of the open and the closed parentheses, and whenever the number of closed becomes bigger than the open parentheses, that means we have an excess of closed parentheses. Remove that closed parentheses, and removing it means just not adding it to the stack. And then start popping in a second path from the stack, and keep track of open and closed parentheses encountered, and whenever the open parentheses number is bigger than the number of closed parentheses, that means we have an extra open parentheses that we should remove, so we remove it, and remove again just means not adding it to the final result. And we construct the final result by adding every new character that we pop from the stack in the front of the result. And yeah, that's pretty much the approach for this problem. Now let's code it and submit it and see if it works. Okay, so now let's code this solution. And so first we need to the first path where we will remove excess closed parentheses. So we need a stack for that, and we need to keep a counter of the opened and closed parentheses. Just one note, we don't need to have 2 variables for the opened and closed. We can increment when we encounter an opened and decrement when we encounter a closed, and check for equal to 0 or less than 0. But just to keep things clear and simple, I'm going to use 2 variables here, and we are going to go through the string and then check if C is an open parenthesis. Then at that point we need to add it, so we have a new opened. And so when pushing, we don't check the open parentheses. It's when popping where we remove the excess opened parentheses. So we need to append that character. Now if it's closed parentheses, then since when pushing we check the excess of closed parentheses, then we push it only if the number of closed is still opened, right? Because if it's bigger or equal, we shouldn't push because we are done, right? and that means if this condition is not verified, that means we have an excess closed parentheses and we are removing it. And removing it is just not adding it to the stack, because the stack will become the final result at the end, right? And so we will increment the closed and we will add to the stack if it's still a valid closed parentheses. Otherwise it's a character, so we can just add it to the stack. So let's just put else if here and add it to the stack since it's a lowercase character here. And now the second pass is where we construct the result and remove the excess of opened parentheses, right? So we need to reinitialize closed and opened. Here in the same way also the opened and closed, we don't need the two variables. We can solve it with just opened parentheses by adding one when we encounter an open parentheses and decrementing one when we encounter a closed parentheses. And so now we are going to go through the stack to construct the result, and we can pop from the stack as we did in the example, and then check if this is an open parentheses, then that's where we handle the extra open parentheses. So if the number of opened is less than the number of closed, then we need to consider that open. But if the number of opened becomes bigger or equal to the number of closed, then we shouldn't add it, right? Because that means that whatever we just encountered is an extra one, and so we need to remove it. And not removing it means just not adding it to the result, right? So that would mean here we have opened +1, and then we add in the front because the stack reverses the order. And then we say if it's a closed parentheses, we already handled closed parentheses here, so anything in the stack is needed, and so we just say close +1 and then add that to the result. And then at the end it's just a character, so that we should add no matter what. And at the end we can return the final result. Okay, so let's submit this. Okay, so looks like for this example it works. So let's just submit. Okay, so that passes. In terms of time complexity here for the solution, we are doing one pass here the first time, and then another path on the stack. And the stack contains at most the number of characters in S. So if we consider the length of S to be n, then our time complexity would be just O of 2n, because we are doing this first pass and this second pass. And O of 2n in time complexity in big O notation is just O of n, right? Now what is the space complexity here? So we are using an extra stack here, right? And the others are just variables, constant space. But for the stack, we add at most the number of characters if the entire string was valid, right? And so in that case, it's O of n. So that's the time complexity for this solution here. Next, we will look at a slightly different way to solve this problem. So what is the other approach that we can solve this problem with? So the other approach is we can just consider the entire string valid and then process it, and whenever we find parentheses that isn't valid, replace it, right? Replace it with an empty string, right? So the way to do that is just have a stack, of course, again, like this. And then let's say in our string that we said earlier, which is code, like this. So we have an excess open parentheses, and let's try it also with the one where we have an excess of, let's say, closed parentheses. So here we have these two. So what we can do is, whenever in the stack here, let's say we are at, so first we are here, so whenever it's so we would have kind of a final result that already contains a list of the content, right? So it's like this. It would contain O, D, E, like this. And now we will process the string. So at this position we encounter that it's an open parentheses, and so we will add the positions of these open parentheses. 0, 1, 2, 3, 3 here, 4, 5, 6. So we encounter that it's a character, so we don't do anything, but then we encounter an open parenthesis. So one of the things we do is whenever we encounter add its index to stack. And so we'll add its index, which is 1, right? Then we will move to the next one. It's a character, so we don't do anything, right? And then we'll go here and we'll find an open parenthesis, so we add its index again, 3. And then character, nothing, E, character, nothing. And then when we encounter a close parenthesis, we check, because if you have an open parenthesis and you encounter a close parenthesis, this portion here is valid, so we don't need to worry about it, right? So we need to keep it in the result. And so we remove that. We pop from the stack. So one of the things we do is whenever we encounter a close parenthesis and the stack is not empty, because if the stack is empty and we encounter a close parenthesis, there is a problem, because maybe we had characters, but there is a close parenthesis that doesn't have a matching open parenthesis, right? And the stack is not empty. That means we pop from the stack, right? Now what I said here is that if we have a configuration like this, that means this is not valid, so we need to remove this one. We need to remove this close parenthesis, right? So that gives us the other thing we need to do is whenever we encounter a close parenthesis and the stack is empty, because in the stack we put the position of open parentheses. So if it's empty, that means there is no open parentheses for that close parenthesis. That means remove that close parenthesis. So how can we remove that close parenthesis? So we have our results list here that already contains the content. So the trick that we can do is just replace, to remove here, what we can do is just replace this close parenthesis with a placeholder, just with any placeholder or any character that you wish for. I'm just going to use a hashtag here. I'm just going to use this one here. And so that means when I encounter this so I encounter this close parenthesis and then I remove this. The other part of this solution is that now I'm done, right? I'm done processing the string, but there is still one open parenthesis here, which is this extra one. So at the end, when I finish processing the string, I need to check at the end, check if stack is not empty. So that means that there is an extra, if it's not empty, so if stack is not empty, that means there is an extra open parenthesis, right? So remove that open parenthesis, right? So how can we remove that open parenthesis? We do the same trick we did with this one, with the close parenthesis, which means just replace that open parenthesis with a placeholder again. Placeholder. And so that open parenthesis is just this, we have the position, right? We put the position intentionally so that we can go and replace it. So here we have the position 2, 3, 4, 5, 6. So that means we go and replace it here at this position. We'll replace this with the placeholder, right? So now in the final step we can just take res. So the final step, take res and join like the element, because it's a list of characters, and replace all occurrences of this with an empty string, right? And so that would mean that our res here will become C, and since we replace this one with an empty string, so it's not there, we have an open parenthesis D, E, and you can see this one here is a valid string, right? Now let's apply that to this one here. let's apply that to the second example. C, open parentheses, we had O, close parentheses, D, close parentheses, and then E, right? So here we do the same thing. Let's take our stack here. C is a character, we do nothing. Let's put the indices 2, 3, 4, 5, 6. So we do nothing, open parentheses, we put the index. So we have our res that is like this, has already C, open parentheses, O, close parentheses, D, close parentheses, E. And then we encounter another open parentheses here, and so we add its index 3. And then we encounter a close parentheses here, so we pop this one, right? And then we have another close parentheses here, right? So this makes... Okay, sorry, actually I messed up a little bit. Let me just roll back. So we have C character, open parentheses, that's position is 1. Close parentheses, that means we pop this up the stack, right? And that's what the... we encounter open parentheses, we add its index, we encounter a closed, stack is not empty, we should pop. So that's what I did. And then we encounter another closed parentheses. But now we are at this condition here. When we encounter a closed parentheses and the stack is empty, we need to remove that closed parentheses. And removing means just replacing it. And so we are at this position, we know the position, right? So we need to just replace that one with the placeholder that we have, right? And so we go to that one, which is position 5. So 0, 1, 2, 3, 4, 5, 6. And replace that with the placeholder, right? And now we move again, character, we don't do anything. And now we move here. Now also the stack is empty, so we do the same thing. So let me just add this to the result, because it would be in it. So we do the same thing, replace the element at that position with the placeholder. And now at the end we just concatenate these and remove any occurrences of these. So now what we need to return is like this. O, D, we skip this, and then E, and we skip that. And this is the final result. And so you can see how this approach works. And we need to just follow the steps that we did here. So next I will code this up and see if it passes the test cases. Okay, so now let's code this solution that we just saw in the overview. And so we need a stack to keep track of the indices of the opened parentheses, right? And we need a result that we will manipulate later to remove the useless open and close parentheses, right? So let's just call it that, like that. And then we go through the string, right? Length of S. And the first thing we do is when we encounter an open parentheses, right? So that would mean S of I is equal to an open parentheses. We need to add the index to the stack. And when we encounter a closed parentheses, we need to do what we said, which is if the stack is not empty, that means we found a closed parentheses that matches with an open parentheses. So we can just pop that because that matches, that's valid, so we don't need to worry about it. But if the stack is empty, that means that we have a closed parentheses that doesn't have a matching open parentheses. So that's a problem. So we need to remove this closed parentheses. And removing it, we say, is just replacing with a placeholder. And so that means in our result, we will, at that index, we will replace with a placeholder. And then after that, we will do while we still have, so this is basically if there is excess of open parentheses, we need to remove them. So if the stack after all of this does contain still some indices, that means there are extra open parentheses, and so we need to remove these. And removing is again just marking them like this. And so since we know the index is just, we already put the index in the stack, we can just pop to get the index and replace with this to mark it for deletion, right? So this is just used here to mark for deletion. And at the end we can just return the string. Since it's a list here, our result was a list here, to be able to mark the indices, we can just join it to construct the string. And then we need to replace any occurrences of the ones marked for deletion with an empty string. like this. And that's pretty much all there is to this solution. So let's just run this and see if it passes. Okay, so looks like that is correct. So let's submit. Okay, so that passes. In terms of time complexity, this solution here, we do one pass on the entire string, and then on the residue of the stack. So at most it would be, if we have only open parentheses, it would be O of 2 to the power of n, 2 multiplied by n. So at most it would be 2n, which is just O of n in terms of big O notation. And in terms of space complexity, we are using only an extra stack and this extra result, right? And both of them can be at most the length of the string. So same thing, it's O of n in terms of space complexity. Okay, so that's it for this problem. Thanks for watching and see you next time. Bye.